Okay, it's another rational function. This one here has a slightly larger numerator, just one term on the bottom, so three terms on the top there. So what you can do is basically split it up into individual sections, and then you are going to simplify it. So now don't be lazy when you do this. Do put the integral signs in respect to x. You're just being thorough. And so the plus is the plus, the minus is the minus. So the whole thing is divided by 3x. Each of these individual terms is divided by positive 3x. So what happens here? The 3's cancel. x5 over x gives you x4. That gives you x over 3. And this gives you negative 5 over 3x. And then we're going to do our integration. That becomes x5 over 5. That's a 1 there. So the add-on becomes 2. Divided by 2, so 3 times 2 gives you 6. Now what happens here, that gives you the natural log with the bars, and we have our plus c. So that is the answer in that one. Okay, they may give you an answer like this, put 1/5 out the front, but to be honest, that's a better looking answer, that one there in fraction form. Okay, so this is where it gets up to solid merit level. What's the difference between this problem and this problem? This one here just had 3x. There was no plus or minus something, okay? Well, you can argue plus or minus 0, but it was just the x term. Whereas here you've got, all of a sudden this minus 2 makes it a long division problem, okay? If we were to go back to your notes here, cat in the background has just tried to jump up and scare the budgie. So someone is dealing with that naughty cat. As it says here, rational function is another way of saying a fraction function. And what we're looking at is algebraic juggling. You need to rearrange your expression so you can differentiate it. Now, if that's you, do look at Mrs. O'Graham here. Algebraic division juggling. Maybe your mindset is good for that, good for you, but to be honest, look at pages 21 and 22 from New Lake is what I do recommend. So very quickly, let's go refresh the screen here. Page 21 and okay, so page 21 here. So there's two ways of doing this. Synthetic division, which to be honest, you'll be taught at university, but I'm old school, and for me, my brain works better with long division. So do encourage you to do the method that you find better, or the algebra jiggling video. Look at the ideas in there. But I'm going to basically, with my examples here, stick to long division in terms of explaining it. So yeah, next page here, click on here, there's a synthetic division problem. There is a long division problem method. So what you're trying to do is divide one bit by another bit, and then by doing that, you've got a numerical answer of how many times that thing goes into that thing and a remainder. And that is another way of writing a function. And that format is more user-friendly to integrate. Okay, Headley stuff. Right, so basically, let's say, for example, you had 17 divided by 3, right? So 17 over 3, and maybe you were taught in primary school, you have this sort of notation. So that's the divisor, that's the quotient. I guess the answer's up here and a remainder, but you go, how many 3's go into 1? Nothing. Okay, so how many 3's go into 17? 5, and you go 5 times 3 is 15, underline, brackets, and subtract. 1 minus 1 is 0, 7 minus 5 is 2. And so your answer is 17 over 3 is 5, because that's plus 2 over 3. And so that would be your answer to 17 over 3. Just confirm, if I were to take this here and put it into fractions, cross multiply, 1 times 3 is 3, plus, what's that, 15 to 17 over 3. So it's the same thing. So the same thing's happening here. So what we do, get rid of that jolly cursor, we say this bit here, 3x plus 3, is being divided by x minus 2. So let's set it up. We've got 3x plus 3 divided by x minus 2. And what we then do is we look at the 3, that number there is 3. We look at this number here. What times that has to be the same as that? So it has to be 3. So 3 times x gives you 3x. And then 3 times minus 2 is minus 6. And then you draw a line, put brackets, and subtract. 3x minus 3x. And the whole idea is you've got to get 0 here, just like we got 0 down there. And then this is the next bit. 3 minus 6 gives you plus 9. So this whole bit here, what you've just done is it's come out to be 3 plus 9, remainder 9 over x minus 2. And look, let's just quickly do this. If we turn this into a fraction, 1 times that is x minus 2, put the plus there. That goes over here. Cross multiply, 3x minus 2 plus 9. Look at that denominator, 3x. 3x minus 2 is minus 6 plus 9. And as you can see, that gives you the plus 3. So yeah, this format here is equal to that format. So the whole objective is to get that, and then we're going to rewrite this as the integral of 3 plus now 9 over x minus 2. And differentiate with respect to variable x. So this becomes 3x. This thing here, 9 pops out, natural log x minus 2, and plus c. That is your answer. Cool.